Hi everyone, I'm doing a video to answer a question about how to enter in the formula for normal CDF for calculating the probability of a proportion or a p-hat. If we look at the form, this is about question number 1 in homework section 7.2. The problem says, according to a survey, 10% of Americans are afraid to fly. Suppose that 1,100 Americans are sampled. That's your N value. The 10% is your population proportion, or P. We want to know what is the probability that 121 or more Americans in the survey are afraid to fly, and you want to write your answer in a percentage. This 121 is your small x value. You'll divide that by the 1,100. We're trying to find the probability that x is greater than or equal to 121. If we convert this into a p-hat, that is 121 over 1,100, we can use our normal CDF to calculate this probability since it's normally distributed. Our lower bound will be our p-hat, or 0.11 in the case of 121 over 1100. You can also use the fraction form. That's okay too. Our upper bound is infinite. I like to use 1e99. I think sometimes you guys like to use 1,000 or 10,000. Either option is fine. Our mean is 0.1, and our standard deviation is the square root of p times 1 minus p over n, making sure to separate each of those values with a comma. I'm going to enter this into my calculator now by hitting second bars to get to the distribution menu and choosing normal CDF. In this case, our lower bound is going to be 0.11 or 121 divided by 1100. Our upper bound will be 1e99. Our mean again will be 0.1, that's our p-value, and our standard deviation will be the square root, and this will be 0.1 open parentheses 1 minus 0.1, close parentheses for the 1 minus 0.1 divided by our sample size, which is 1100, and then close parentheses for the square root, and we'll paste this. And then if you have a ti84, you'll want to make sure when you type it into the home screen it looks the same way, all separated by commas. And when you hit enter, our value will be 0.13446 or 13.45% if we round to 2 decimal places.